The year was 2011, and the web was becoming a dangerous place for the chaotic. In the pristine, glass-walled offices of Google in Mountain View, a sense of unease had settled over the engineering leadership. They had built Chrome, a browser that was rapidly devouring market share, and they had built V8, an engine that made JavaScript run faster than anyone had thought possible. Yet, for the architects of the modern web, speed was not enough. They looked at the sprawling, untyped, and erratic nature of JavaScript and saw a structural weakness that threatened the colossal scale of applications they intended to build. They believed the foundation of the internet was cracking under the weight of its own success. It was in this atmosphere of quiet urgency that Lars and Kasper Lund stepped onto a stage in Aarhus, Denmark. They were not merely presenting a new tool, they were unveiling a replacement. They introduced Dart, a language designed with a structured, class-based elegance that JavaScript lacked. It was a language built for productivity, speed, and tooling.
You spent the last 2.5 years working on Dart, so finally it's out and it seems like it's well received. So fantastic new platform for writing web applications.
It was the weapon Google intended to use to bring order to the wild west of web development. The premise was simple but arrogant. They believed that for the web to evolve, JavaScript had to be sidelined. They marketed Dart as a batteries-included solution, a cohesive ecosystem that would run natively in the browser, bypassing the unpredictable quirks of the existing standards. The reaction was not the applause of a grateful industry, but the sharp intake of breath that precedes a fight. The developers of the open web did not see a savior. They saw a walled garden. The controversy began almost immediately, fueled by a leaked internal memo titled Dash, the original codename for the project. The memo suggested that the ultimate goal was not coexistence but dominance, a strategy to fracture the web so that Google's language would become the new standard. This political misstep haunted the language for years. It framed Dart not as a technical innovation but as a corporate power grab. The resistance was institutional and absolute. Microsoft, which was heavily invested in its own TypeScript project, had no interest in adopting the Dart virtual machine. Mozilla, the guardian of the open web and creator of Firefox, flatly refused to support it. Apple, with its iron grip on Safari, remained silent and immovable. Without the support of these browser vendors, the dream of a Dart-native web collapsed. The language that was born to kill JavaScript was forced to become a transpiler, a tool that merely converted its clean code into the very JavaScript it sought to destroy. It was a humiliation. By 2015, Dart was viewed by the broader industry as a walking ghost, a piece of Google infrastructure that was technically sound but culturally dead. Yet, within the sprawling data centers of Google, Dart refused to die. It survived because it was useful. The Google Ads team, responsible for the vast river of revenue that powered the entire company, had adopted Dart for their massive front-end interfaces. When billions of dollars are at stake, engineering reliability becomes more important than developer trends. The ads team needed a language that could handle millions of lines of code without collapsing into a tangle of errors. Dart provided that safety. This internal economy kept the heart of the language beating, while the rest of the world looked away. It generated revenue in the billions, silently proving that the language was capable of enterprise-scale heavy lifting, even if the public sentiment remained cold. While Dart lay in this dormant state, a different crisis was brewing in the mobile world. The era of the desktop was fading, replaced by the glowing rectangles of smartphones. Developers were trapped in a dilemma. They could write native code for Apple's iOS and separate native code for Google's Android, doubling their work and cost. Or they could use hybrid frameworks that wrapped web pages in a mobile shell, resulting in sluggish, jerky apps that felt cheap and unresponsive. The industry was desperate for a third option. Facebook attempted to solve this with React Native, a framework that allowed developers to write in JavaScript while controlling native components. It was a massive success, but it had a fatal flaw. To understand this flaw, one must visualize a bridge. In React Native, the logic of the application lives in a JavaScript realm, while the user interface lives in the native realm of the phone. Every time the app needs to update the screen, data must pass across this bridge, like a message being passed between two people speaking different languages. When the data is light, the conversation is smooth, but when the data is heavy during a complex animation or a rapid scroll, the bridge becomes a bottleneck. Traffic jams occur. The app stutters. The illusion of smoothness breaks. This technical limitation was the source of immense frustration for engineers who wanted to build high-performance experiences. In a small corner of Google, a team known as the Sky Project was experimenting. Led by Eric Seidel, they were stripping the Chrome browser down to its bare essentials to see if they could build a faster rendering engine. They removed the HTML. They removed the CSS. They kept only the Skier graphics engine, the raw drawing tool that could paint pixels on a screen with blinding speed. They had the engine, but they lacked a steering wheel. They needed a language to control this engine, one that was fast, predictable, and capable of keeping up with the harsh demands of 120 frames per second. They tested JavaScript, but it struggled with the bridge problem. They tested nearly a dozen languages. Then, they looked down the hall. The Dart team, humbled by their failure in the browser wars, was looking for a new purpose.
Flutter started out with a very different purpose than it has now. Flutter started out as just trying to make the web better. We were trying to make Chrome better, trying to make Chrome smaller.
The Sky team, which would eventually become the Flutter team, made a proposition. They would use Dart, but only if the language could evolve to meet their specific needs. This was the turning point. It was a moment of serendipity, where a solution in search of a problem met a problem in search of a solution. The technical marriage between Dart and Flutter was built on two distinct ways of compiling code: just-in-time, or JIT, and ahead-of-time, or AOT. Most languages specialize in one. Dart, uniquely, excelled at both. This duality became the secret weapon of the Flutter framework. During development, when a programmer is writing code, Dart uses a just-in-time compiler. This allows for a feature known as stateful hot reload. It is like editing a film while the projector is still running. A developer can change the color of a button or the logic of a function, and the app updates instantly on the phone without losing its place or restarting. This reduced the feedback loop from minutes to milliseconds. It induced a state of flow for developers that was intoxicating. It transformed the agonizing weight of mobile compilation into a fluid, creative process. However, a just-in-time compiler is too slow for a production app running in a user's pocket. It requires a virtual machine to be running constantly, consuming battery and memory. This is where Dart's second nature takes over. When the app is ready for release, Dart switches to ahead-of-time compilation. It compiles the code down to native ARM machine instructions, the raw binary language of the processor. It strips away the virtual machine. It eliminates the bridge. The app becomes a self-contained binary that speaks directly to the hardware. This architecture allowed Flutter to bypass the bridge problem entirely. Instead of asking the phone to draw a button, Flutter uses the Skier engine to draw the button itself, pixel by pixel. It controls every dot on the screen. This gave Flutter apps a consistency that was previously impossible. An app looked identical on an old Android phone and a brand new iPhone, because Flutter was not relying on the phone's interpretation of a design, it was dictating the reality of the interface. The Renaissance began in 2018 with the official release of Flutter 1.0. The tech world, initially skeptical of another Google project, began to take notice. The adoption curve was not a gentle slope but a vertical wall. It was driven not by hype, but by the sheer economic utility of writing an app once and deploying it everywhere. The list of organizations that migrated to this technology reads like a ledger of the global economy. Alibaba, the Chinese e-commerce giant, adopted Flutter to power parts of its massive marketplace, serving tens of millions of users. They needed speed and scale, and the Dart-powered engine delivered it. In the financial sector, Nubank, the largest fintech bank in Latin America, rewrote their entire mobile experience in Flutter. They were handling the life savings of millions of customers. They could not afford errors. The strong typing of Dart, which had once been criticized as too rigid, was now seen as a necessary safeguard for financial security. Even the automotive industry, historically slow to change, embraced the technology. Toyota selected Flutter to power the infotainment systems in their next generation of vehicles. They were not building a simple phone app. They were building an embedded interface that had to survive the lifespan of a car. They needed a system that was performant and stable. The decision by Toyota validated Dart not just as a mobile language, but as a universal language for ambient computing. The financial impact of this shift is difficult to quantify, but impossible to ignore. The Google Play Store and the Apple App Store generate hundreds of billions of dollars annually. By 2021, Google announced that over 200,000 apps in the Play Store were built with Flutter. Today, that number has grown significantly. These apps drive commerce, banking, social connection, and enterprise logistics. The code that Lars and Kasper Lund wrote, once rejected by the browser vendors, now underpins a significant fraction of the digital economy. However, the journey has not been without lingering controversy. The shadow of Google remains a point of tension. Critics argue that by adopting Flutter and Dart, companies are handing control of their digital infrastructure to a single advertising giant. There is a fear, born of experience, that Google could one day lose interest, killing the project as they have killed so many others, like Google Reader or Stadia. This is the Google graveyard anxiety. To combat this, Google worked to make Dart open source and governed by a broader committee, but the skepticism remains. Furthermore, there is a legal and political dimension to the cross-platform wars. Apple has historically been hostile to technologies that allow developers to bypass their native tools. While they have not banned Flutter, the threat of policy changes looms like a storm cloud. If Apple were to decide that apps must use native interface elements for security or aesthetic reasons, the fundamental premise of Flutter, that it draws its own pixels, could become a liability. This tension keeps the ecosystem in a state of vigilant alert. Comparatively, Dart occupies a strange position in the hierarchy of languages. It is often compared to Swift, Apple's native language, and Kotlin, the standard for Android. Both Swift and Kotlin are modern, safe, and loved by developers. Yet, they are bound to their specific platforms. Dart's strength is its nomadic nature. It settles nowhere, so it can live everywhere. It is less elegant than Swift and perhaps less concise than Kotlin, but it offers a singular value proposition: ubiquity. There are lesser-known facts that highlight the strange evolution of this technology. For instance, the Dart team implemented a feature called Sound Null Safety in version 2.12. This was a massive undertaking that fundamentally changed how the language handles the concept of nothingness. In most languages, a null error is a common cause of crashes. It is the billion-dollar mistake. Dart retrofitted its entire ecosystem to make these errors impossible at the compiler level. It was like changing the engine of an aeroplane while it was in mid-flight. The success of this migration demonstrated a maturity that few other languages have achieved. Another obscure but telling detail is the usage of Dart in the Fuchsia operating system. Fuchsia is Google's mysterious, long-gestating project that many believe will eventually replace Android. The user interface of this new operating system is written entirely in Dart. This suggests that the language is not just a tool for today's apps, but is being positioned as the native tongue of Google's future hardware. The cultural impact of Dart is visible in the democratization of app creation. Before frameworks like Flutter, building a high-quality app required a team of iOS specialists and a team of Android specialists. It was a luxury reserved for well-funded startups and corporations. Today, a single developer in a bedroom in Lagos or Mumbai can write a single codebase in Dart and publish a world-class application to billions of devices. It has lowered the barrier to entry for digital entrepreneurship. It has shifted the power dynamic from large teams to individual creators. The prose of the code itself has changed the psychology of development. Because Dart is optimized for the UI, or user interface, it uses a declarative style. This shift requires a mental rewiring. It moves the developer from a mechanic, turning dials and gears, to an architect, drafting blueprints that the machine builds instantly. In the end, the story of Dart is a study in resilience and adaptation. It began with hubris, aiming to dethrone the king of the web. It was beaten down, humiliated, and exiled from the browser. But in that exile, it found a new identity. It stopped trying to be a better JavaScript and started trying to be the best possible engine for pixels. It succeeded not by conquering the world it was born into, but by waiting for the world to change until it fit the shape of the language. Today, when you tap the banking app on your phone, or adjust the climate control in a modern car, or scroll through a marketplace, you are likely touching the work of that quiet team in Mountain View. They did not kill JavaScript. Instead, They built a parallel reality, a layer of paint over the digital world that looks the same regardless of the device beneath it. The tension of the early days has faded, replaced by the steady hum of a billion devices executing Dart instructions. The revolution was not the explosion they planned. It was a slow, inevitable seep into the infrastructure of modern life.